Hi, I'm Sue Hinton, the leader of TIA's Water for Profit program. The aim of that project has been to work with farmers to improve their approach to managing their irrigation efficiency, and so we've been involved with our partners on the project, Pinion Advisory, and we've worked closely with the farmers in a peer-to-peer group arrangement where they've learnt from each other, we've learnt from them, and we've been trying to actually work to improve how they manage their water and also look at their energy consumption and energy costs and try and make that system much more efficient.
G'day, I'm David McLaren. I'm a Senior Project Officer in Irrigation for the Tassie Institute of Agriculture, and today I'm here at Forester Lodge, which is in Waterhouse, the northeast of Tasmania, and I've got John Wilson here today with me. John, just give us a few words about the irrigation platform and what goes on here.
So it's about 450 hectares all up, and about 230 of those are irrigated. What happened was we inherited the irrigation infrastructure that was on the farm, which was more around smaller pivots that were more suited to cropping. So they're about 25 hectares each. So there's actually 9 pivots on the farm over the 230 hectares, and they're sourced water from the Great Forester River. There's 2 pumping points. At the moment, the farm's milking around 900 cows. We tend to be very much pasture-based. Production levels sit around the 450 to 480 kilos of milk solids a cow, and grain inputs, which is the other part of the equations, we'd probably target around 1.2 tonne a cow. So we had to get to a situation where we could run all of the pivots at the same time. That required resizing the pack sizes on the pivots. Coming back to 5.5 mils in this environment means that the pivots need to be running for 24 hours. Basically every day through the peak of the irrigation season. So there's very little redundancy time involved. So it's quite critical that these pivots continue to run. The pivots on the place, they probably range in age from about 20 years down to about 6 years old. So there's issues just with older hardware. The other issue that probably came out was that irrigating continuously right through, we discovered that there were some wet areas on the farms that needed track maintenance and that type of thing.
Shifting water efficiently and distributing water in a uniform manner are 2 different things, and there's some of the key learnings for you. And even as you unpack some of the nuts and bolts, irrigation system design is complex. It does require specialist help. And then also the other key thing, it's really you have to measure to manage. Until you get in there and take some fundamental measurements around uniformity of application, around required pressures, around delivery rates, that's where the efficiencies come with irrigation, and that's where what we've found is that they can bleed off significant amounts of cash from the farm business unnoticed unless they're managed. A lot of the time we look to identify the low-hanging fruit. Sometimes changes that can have a big impact are not expensive fixes. So routine maintenance and unblocking nozzles and uniformity, some of these fixes are not expensive. So we can target low-hanging fruit first, and then sometimes it requires significant investment. But we also like to look at the low-hanging fruit. So when we think about the pump not supplying adequate flow or pressure, we need to think about the reason why. Now that could be a number of factors as to why that's not supplying the adequate flow and pressure. And the first question you need to ask is, what is the required pressure and flow rate for the irrigation system? So you need to find that detail, and that's often, when we talk about centre pivots, it's on the nozzle chart. So that will have a required or a designed flow in litres a second and a designated pressure in kPa. So once you know that, then you can measure your flow rate and take your pressures and know if your pump and infrastructure is meeting the design duty point. If it's not, why? So typical problems can be a depletion in performance, which can be caused by issues like cavitation, and that's wear on the pump impeller, which will reduce performance. The other issue is it may not have been designed adequately. So the pump and motor that you have in place are not designed or adequate to meet the duty. So it comes down to system design that may not have been done correctly, and it also comes down to the depletion of performance, which is caused by wear and tear of the infrastructure. One of the main issues that we've had here at this particular site is cavitation of pumps, and what can be summarised there when it comes to the performance of pumps is a term that we call net positive suction head. So what happens when a pump cavitates is you get a depletion in performance, and then the duty point that pump should be meeting, it no longer meets. The electric motor attached to the pump has to work harder, and damage is also imparted to the pump. You can see here that there's holes in this impeller. So as that water turns into its vapor state, it explodes on the face of the impeller and really rips the impeller apart. So with that depletion of performance, it costs money, you won't get the targeted flow rate, and it damages your infrastructure. So that's a real key issue that we want to address. So to mitigate that, it's so important on the suction side of the pump that the sizing of the suction line is adequate. If there's screens on the inlet side of the pump, they need to be functioning properly, not blocked with debris. And that's when cavitation can occur in a lot of times. If there's debris all over the foot valve or self-cleaning screens like that, then you get an impediment of flow, and cavitation can occur and cause this sort of damage. The nozzle package on a centre pivot irrigation system, it's been said that it represents about 7 to 8% of the initial capital investment, but 80% of the machine's performance. So the nozzle package has a critical role, and it's important that performs correctly. Now, every machine will have a nozzle chart, and it's provided from the manufacturer with the machine, whether that's Nelson or Synerger or whoever makes the nozzle chart for your centre pivot irrigation system. It provides some key fundamental performance metrics of how the nozzle chart should perform. So the first thing you want to look at as you assess your nozzle package and its performance is, does the machine have the right flow rate, and does the machine have the right pressure? And both of these are found in the nozzle chart. It will say the required flow rate into the machine and the required pressure. Then the other detail that the nozzle chart also provides is the outlet number, the nozzle size, the nozzle colour, and its position on the machine. So the machine will have an order of how the nozzles are ordered on that machine. So as you come up to a nozzle and it's broken, you can see what nozzle type, what colour, and you need to make sure that if that's broken, you don't just replace that with any nozzle or any sprinkler. You can refer back to your nozzle chart as a guide and replace it with the correct nozzle, correct colour, and the right sprinkler head. Wheel ruts and bogging is a significant issue out there and causes a lot of damage and downtime for machines. Machines breaking drive joints and getting bogged and stuck and downtime, machines having to be pulled out. So what causes wheel ruts and bogging is that the centre pivot tower structure itself acts as a bit of a funnel. Having the correct tyre size and inflation is helpful. The main issue to deal with wheel ruts and bogging is getting the water away from the structure and preventing it dropping into the wheel rut. So there are dry wheel packages available as an accessory for centre pivot irrigators, and what that does is you change the dropper around the tower structures. This is a flexible one, but you change that to a solid dropper with a 180-degree throw. So that will then throw water away from the tower structure, preventing it gathering on this lattice structure and dropping in your wheel ruts. The other way you can deal with it is by adding boom backs. Now boom backs they get the water away from the tower structure by taking the nozzle 3 or 4 metres back and throwing the water behind the machine. So it's all about getting the water away from the tower structure to prevent the significant issues that are caused by wheel ruts and bogging and trafficability. Now, a catch can test is a test done in the field while the machine's running, and you set out these cans that I've got lined up here behind me, and they're placed throughout the whole length of the machine, normally at 3 metre intervals. And the machine is then started and brought up to pressure, ran across those cans, and you can evaluate from the depth of application caught in those cans how uniform the system is applying water across the field area.
Each of the growers that participated in the program, we did a catch can, which Dave has explained. And the thing that surprised us was that none of the pivots that we did a catch can actually met the expected distribution uniformity. And so that was a really good tool for us to work with the groups of growers around what we could do to try and actually improve their application efficiencies for their pivots.
So water quality issues can occur with mineral deposits in the water and also sediment. So as we're going through a pressurised irrigation system, these can create problems. So the biggest one that I've witnessed is sediment and debris in the water, particularly in river take systems where you have a highly mobile environment with willow leaves and bark and twigs and debris. And so they can certainly cause dramas for the irrigation system. That can obviously create a few problems. It could not only block the foot valve on the intake side of the pump, but that sediment can also be sucked into the pump and pushed through the entire pipework and right through to the nozzles on the centre pivot irrigation system and create blockages and havoc and problems along the way. Minerals and acidic issues with the water can also cause corrosion, so we need to ask the question how we can combat those and address the issue. So when it comes to sediment, the way we can deal with that is through filtration. Today there's many types of self-cleaning screens that can go on the foot valve or the suction side of the pump. These will keep the debris out of the pump and the irrigation system, and they're self-cleaning, so they operate and they can maintain a clean water source for the pump. If it comes down to minerals and other contaminants in the water, you may have to flush the irrigation system and purge at the end of the season or regularly throughout the season. So if you've got galvanised pipe infrastructure through the centre pivot, it's about getting that water out so it doesn't sit idle there. And there's other ways you can do it. If it's a real problem, you might need to look at poly-lined pivots and other ways you can deal with minerals in the water.
It's been very much an awareness thing on the technical side for me. Yep. We're basically looking at other reasons or outside reasons why we're having these issues, where it was very basic that the suction lines and the filtering systems wasn't adequate and was just causing cavitation of the pumps, and so yeah, we were just chewing out impellers. I suppose I've learned a lot about, well, two things. One is don't assume what's there is right.
Yes.
And the second thing is that there's a lot more detail. It's not just about poking a pipe down into the river. There's a lot of detail and a lot of technical stuff that goes behind that.
Yes.
So you really got to rely on some expertise around that, and needs regular maintenance.
Yes.
The pressure gauges, actually have one at the centre, have one at the end, but the most important thing, have ones that work.
Yes. Okay, John, so thinking about the Water for Profit program that you've been an active participant in, if this a program like this was to be extended or run again in the future, would you encourage other farmers to get involved in a project like this?
Yeah, very much so, Dave. Look, we spend so much money on irrigation infrastructure, on power to run these things. Look, just the small key learnings have such an impact on this business, and the improvements that we're making just by identifying issues. Yeah, I would encourage any farmer to be involved.